So today our lesson is similar solids. Now, similar solids have exactly the same shape, but not the same size. Now, if they had the same shape and size, they'd be congruent. They'd be identical, but they're not. They're similar because they have the same angles are the same, but the measurement of the side lengths or other lengths are different. So two solids are similar if the ratio of their corresponding linear measurements are equal. So, now when we talk about linear measurements, we're talking about length, height, width, slant height, perimeter, radius, diameter, and circumference. So those are all linear measurements. They're not area, they're not volume, they're linear measurements. Okay, so here it says, determine whether the solids below are similar. If yes, give the scale factor in simplest form. So let's compare apples to apples here. So we have 12 to 3. 12 to 3. That's, if I reduce this, 4 to 1. 8 to 2. 8 to 2. If I reduce that, 4 to 1. Then I have 20 to 5. 20 to 5. If I divide 5 in each of those, I get 4 to 1. So the scale factors are all the same, so I would say yes, similar. The scale factor is 4. We'll put it this way if we're going to do 4 to 1. Okay, number 2. Now, number 2, let's compare these. So the height here, 8 to 12, that's the same as divide 4 into each, 2 to 3. Now here, this width here, 6 to 10. If I reduce that, that's the same as 3 to 5. And on this side, 6 to 10, 3 to 5. So you notice that the scale factors are not all the same. So these would be not similar. Not similar. Now, if I look at number 3, compare to it, I see I have a radius here, so I'd make this a radius. This would be 12. So I'd say 12 to 10. If I reduce that, divide 2 in each one, I'm going to add 6 to 5. Now I'm going to look at the height. I've got 30 to 25. So if I divide 5 into both, I'd have 6/5. So the scale factors are the same, so I would say yes, similar. The scale factor would be 6 to 5. Okay, comparing volume and surface area. If two solids are similar with a scale factor of A to B, then their volume and surface area ratios are as follows. The surface area ratio would be A squared to B squared. The volume ratio would be A cubed to B cubed. So let's look at an example. It says identify the scale factor / ratio for each pair of similar solids. Okay, so all we have to have is one ratio to tell us they're similar solids. So here I've got 6 to 3. 6 to 3. Now if I divided 3 into each one, I'd have 2 to 1. Now this is a linear measurement, so it's going to go with scale factor 2 to 1. Now, if I want to go to see the surface area ratio, if I was comparing the surface areas, I would square this. So 2 times 2 is 4. 1 times 1 is 1. Now, I want the volume ratio. So I always go back to the scale factor. Now, volume is cubic. So I'm going to cube 2. 2 times 2 is 4 times 2 is 8 times 1 times 1 times 1 is 1. Okay. Let's turn the page over. So let's look at number 6. So, when given surface or volume, always find the scale factor A to B first. Okay, so I see here that we're talking about feet squared, we're talking about surface area, so that's going to be this one, right? So let's see. So we have 25 to 4. Now, can I reduce this? No. And that's surface area, so it goes here, 25 to 4. That's my surface area ratio. Now, I always want to go back to the scale factor first. So, to go backwards, I'm going to take the square root of this. So, the square root of 25 would be 5. The square root of 4 would be 2. Okay, so that's my scale factor. Now, they want the volume ratio. So what am I going to do now? Take the scale factor and cube it. So 5 times 5 is 25 times 5, 125 to 2 times 2 is 4 times 2 is 8. Okay. Now, let's look at number 7. So 7, you notice here, volume cubic. So we're going to be finding this first. So let's see. Now, here we've got 162 to 384. Now, I want to reduce that. Let me show you that I didn't recognize it till last period or so. Let me show you how to reduce this with your calculator. So with my calculator, I'm going to put in 162 divided, did I do that right? Just a minute. 162 divided by 384, and I'm going to hit enter. Okay, now I'm going to go math, enter. So that tells me 27 over 64. Okay, so I have 27 to 64. Now, we said that was volume, so it goes here, 27 to 64. Okay, now, I always want to go back to scale factor first. So what do I do to this? Cube rooted, right? Now let me show you how to do that on your calculator if we don't know that already. So I'm going to put in 27. I'm going to hit the caret key. I'm going to raise it. Now I'm going to put in parentheses to the 1 divided by 3, close parentheses, to the 1/3 power, 3. Okay, now I can do the same for this, but I know that 4 times 4 is 16 times 4 is 64. Okay, now I want to go to surface area. So what do I do now? Square the scale factor. Good. So 3 squared is 9, 4 squared is 16. That's the way we do it. We always go back to scale factor, then go forward. All right. Now let's look at number 8. So number 8, we're talking about surface area, and we've got 960 to 375. Now, put that in your calculator and see what kind of a fraction you get. 960 divided by 375, we get 2.56. Now, if we go math, enter, let's see what that's going to give us. 64 over 25, right? 64 over 25. Now that's surface area. So we're going to go here. We're going to say we have 64 to 25. Now, what are we going to do? Go back to scale factor. What do we do when we go backwards? Take the square root, right? So that would be 8. Square root of 25 would be 5. Now we want to go forward. We want to cube 8. So if you cube 8, 512, cube 5, we get 125. Okay? All right. Now, so let's look at the word problems. So this one says solid A is similar to solid B. The ratio of the height of solid A to the height of solid B is 7 to 3. So we got the ratio of the height of A to the height of B is 7 to 3. Okay, so that's a measurement, right? 7 to 3. Now it says find the ratio of the volume of solid A to solid B. So if this is heights, we're going to what? Cube, right? So that's going to be how much? 343 to 27. And we can write it like that, or we can say 343 to 27. Either one. Either way is correct. All right. Let's look at number 10. So number 10 says cone A is similar to cone B. The ratio of the surface area of cone A. So I have the surface area of A to the surface area of B, and that's 16 to 1. 16 to 1. That's surface area. So where am I going to go first? Back to scale factor, right? So going backwards, I'm going to take the square root of this. So I'm going to have 4 to 1, right? Then it says find the ratio of the radius. Find the ratio of the radius of cone A to cone B. Well, that's what we did. We went back to scale factor, and radius is a linear measurement. So we have 4 to 1. All right, let's look at number 12. So number 12, pyramid A and pyramid B are similar. Pyramid A has a volume. So a volume of A of 648. A volume of B is 1029. Now this is a good one to put in your calculator. 648 divided by 1029 divided by 1029. So then we're going to go math, enter. 216 over 343. 216 over 343. Now, this is the volume of A to B. That's the factors for the volume. What's the ratio of the surface area? So where are we going first? Back to the scale factor. So this is volume, so we're going to cube root this, right? We're going to cube root it. So if we do that, what do we get? 6 to 7.
Well, how do you cube it again?
I'm taking the cube root. I'm going to put in 216 and raise it to the, in parentheses, 1/3 power. And that'll give it to me. Okay, so we do that, we get 6 to 7. Now that's the scale factor, the linear factor. What is the ratio of the surface area? Okay, so now what am I going to do?
It would be 36 to 49.
36 to 49. 6 squared is 36, 7 squared is 49. Okay, go ahead and finish up the other couple that we haven't done.